Hi, I'm Elizabeth,
Hi, I'm Benton.
and for our programming project, we decided to do the programming competition, and our team name is Major Cardinals. When we started this project, we decided to look through the code base, and we determined that there was three things we wanted to focus on: parallelize the code, find the bottlenecks, and then improve the serial code. One of the first things we decided to look at was how joins were being done. Originally, the code contained a serial hash join, where the hash table was built on the left table, and then the right table looped through and probed the hash table. We wanted to make this faster by parallelizing it. To do this, we split the right table up into chunks and sent each chunk of data to its own thread, which then probed the hash table to get the left data to merge. Each thread had its own results, otherwise there would be race conditions. Once we had the data for each thread, we needed to merge the data. Overall, these changes proved to be helpful and allowed us to pass the small, medium, and large tests on the server. But we still needed to do more in order to pass the extra large.
After we finished parallelizing the probe phase of the joins, we also decided to parallelize the step where we merge the temporary results into the total results. Each thread got its own column that it was responsible for, and it would merge that column into the total results, since we're using column store. After we did this, we were able to pass all the online tests in about 162 seconds.
Parallelizing the merging on the columns was an improvement. However, some of the tables only have 1, 2, or 3 columns, which means that this code actually isn't that parallelized. In order to make this better, we decided to additionally split on chunks within the columns. So each column is still in its own thread, but there might be multiple threads containing the same column, which will get their data separately as they can directly input it into this array.
After we finished parallelization of joins, we also applied the same ideas to self-joins and filter scans. So basically splitting the work among workers and then merging their temporary results in parallel. And we also decided to employ some thread pooling with a tiny library that we found online so that instead of having to spawn a new thread, we could just reuse existing threads. And this kind of helps reduce some of the overhead of spawning threads.
Since we're storing intermediate data, we thought it might be beneficial to store less data. To do this, we considered storing the row ID instead of the value for each column. However, since the number of columns used in these queries is very small, often 1, 2, or 3 columns, this was not successful and actually made our code slower.
Now we'll talk about some of our ideas that didn't turn out to be successful. One of those was with query plan reordering. So we tried a couple really basic heuristics like moving the primary key joins to the start and make sure we do them first. And that actually worked okay. But we tried some other very simple things like doing smaller relations first. And we didn't have as much success with those, which kind of makes sense because smaller tables could be joined on things that are very not unique between columns, and it could be closer to a full cross product. But in general, we thought that if we had more time and we were a little more confident with moving things around from the pre-processing phase to using that information later on in the program, we think it may have been possible to do something similar to like we've been talking about in class so far with histograms and selection estimates. But we also noticed that some of the queries that were run by the test cases were actually very small, so it'd only be a couple joins or filters at a time. So we didn't know how big of a difference that would make.
We did our best to explore the data and improve the code, but there are some areas that could use some work still. One of these is pre-processing. We were given 60 seconds to pre-process the data, and we didn't focus on this, so we didn't really use this time, but we think it could make the code a lot faster. We also think better join ordering and bushy query plans would be beneficial.
Another improvement that we think we could make is doing some sort of load balancing among threads. So right now, when we do the hash join, we give each thread an equal number of rows to join on, but this could lead to some threads being slower than others. So we could deal with this by either having idle threads steal work from some of the slower threads, or by trying to do some sort of heuristic and partition in a more even manner so that there is no imbalanced work, or at least try to get more even work.
We also think we could improve the system by doing two-way partitionings of the joins, and partitioning on the left and the right. Now we can join each partition individually, and then in order for this to work, we also need balanced partitions.
Currently, our code passes all the tests online in about 115 seconds, and while it isn't the fastest, we definitely had a lot of fun doing the project.